This is a lesson on significant figures. Significant figures can seem like a pain, but they're actually very important in science class and in the scientific community. Significant figures are a way of rounding numbers so that based on the number of significant figures written in the number, you can tell how carefully the measurement was measured. Was it measured as a quick estimate, or was it something that was measured precisely with a very nice instrument? Though that makes a difference in how scientific data is interpreted. So as an example here, I've got the times for the 100-yard dash from Olympics in the past. And if you look at these times, you'll see that before about the 1960s here, the times were recorded to the 10th place. After that time, most of the times were recorded to the 100th place. The reason for this change is probably because a better instrument was used for measuring the times of the 100-yard dash. Most likely, when the recording changed, they probably changed from some kind of manual stopwatch timing to using more of a digital start and stop for the time. So this is something that indicates how carefully the time was measured. So when you're looking at a number, you're going to need to interpret how many digits within that number were measured carefully. How many of them were measured well. There are two different ways to do it. I'm going to teach you both ways in this video, and you can choose whichever way makes the most sense to you. The first way is kind of a cutesy little trick for remembering, but it does not point to why the numbers are actually significant. This is called the Atlantic-Pacific Rule. So if you're looking at a number, the first thing that you ask yourself is there a decimal present? If there's a decimal present, you're going to do your counting from the Pacific Ocean side of the number. So the way you remember it is Pacific Ocean when the decimal is present. If there is not a decimal, then you will begin counting from the Atlantic Ocean side. So you remember no decimal point, the decimal is absent. Start from the Atlantic Ocean side. So you're going to start from one side of the number or the other, and you're going to start counting, just counting like 1, 2, 3, 4, 5 when you get to a number that's not 0. And you stop when you get to the end of the number. We'll look at an example in a minute. The second approach you can take to interpreting significant figures is to learn and maybe a little bit more understand why numbers are significant and why they're not. In the simplest way to think about it is that if a number is written with intention, it's significant. If a number is written more just to be a placeholder, then it might not be significant. So there are 5 rules. The first rule is that all non-zero numbers are significant. This is the easiest one, and it doesn't usually trip students up too much. So for example, in a number like 123.4, that has 4 significant digits because all of the numbers in 123.4 are not 0. So they were all written there for a reason. None are placeholders. They're all significant. Zeros are the thing that makes significant figures tricky because sometimes zeros are written just kind of to hold a place, and sometimes they're written with a little bit more intention. So in this second rule, zeros between non-zero numbers are always significant. So this 0 right here is sandwiched between a 2 and a 4. It's not just there to hold a place, it is there between significant numbers. So it must be significant, and that whole number has a total of 1, 2, 3, 4 digits that are there for a reason, that are significant. Leading zeros, and what I mean by a leading zero is any 0 in front of a non-zero number. So this 0 and these 2 zeros are all 3 leading zeros. They are not significant because these 3 zeros are just here to give you an indication that this 6 is not in the 10th place, it's not in the 100th place, it's in fact in the 1000th place. So these 3 zeros are placeholders. Leading zeros are not significant, so there are only two significant numbers in this problem, or in this number. When a decimal point is written, so in this number there is a point right there, trailing zeros are significant. So I've got a point, I wrote this number here, I didn't have to write that. It didn't change what place value any of the other numbers are in, so it was written with intention. Someone put it there on purpose. Therefore, it's significant. And there are 1, 2, 3, 4, 5 significant digits. But if there's not a decimal point written, so for example in the number 120, the trailing zero, the one at the end of the number, is not significant. So this zero is insignificant. It is there more with the purpose of telling you that the 2 is in the tens place rather than the ones place. So only the 1 and 2 are significant, and this has 2 sig figs. So next we're going to look at some examples so you can get a better idea of how either the memorizing and understanding the rules or the Pacific Atlantic Rule work to help you determine the number of significant figures in any number. The first one will start you out with something fairly easy. In this number, 479, there are no zeros. All the digits, therefore, have to be significant, and this contains 3 significant figures. The second number, I'll start with the Atlantic-Pacific Rule. This number, the decimal is present, so I'm going to start on the Pacific Ocean side of the number. That's over here. I'm going to start counting when I get to a non-zero number. So I'm passing by the zeros, and I start counting here. 4, 5, so 1 and 2. Therefore, there are 2 significant numbers, 2 significant digits in this number. If you prefer the understanding side of things, these 2 zeros are really just placeholders telling you that this 4 is in the hundreds place. So they are not significant, they're just placeholders, only the 4 and the 5 are, and you still come out with 2. The next 2 examples kind of go together and show you how adding an intentional decimal point, like in the second, can change, indicating a different number of significant figures. If there's a decimal absent, these zeros are just there to tell you that the 5,000 is in the thousands place, and there's only 1 significant figure. If you like the Atlantic-Pacific Rule better, the decimal is absent, it's not written, so you're going to start on the Atlantic Ocean side of the number. Start counting when you get to a number that's not 0. So I'm passing by these zeros, I start counting at the 5, I only can count up to 1 before I get to the end of the number. But now things change. I've made a decimal present. I've done something with intention. These zeros were written there with a little bit more thought behind them. So they are, this time, just by putting that little dot, considered significant. And now this number has 4 significant figures. If you think about it with the Atlantic-Pacific Rule, now a decimal is present. I start counting from the Pacific side of the number. I start counting when I get to a number that's not 0, so here, and I stop when I get to the end. 1, 2, 3, 4. So I still come up with 4 significant figures. The fifth example has zeros all over the place. We've got zeros in the front, zeros in the middle, zeros at the end. Leading zeros are always just placeholders to tell you the value of another number in the decimal. So those first 3 zeros are not significant. The 3 is. Zeros in between must always be because there's intentional numbers on either side of them. The 8 must be significant. Now we get to trailing zeros. Trailing zeros count if there's a decimal there. There is, so these 2 are both considered significant. So we have a total of 5 significant digits here. Scientific notation actually makes significant figures much easier because if a number is written in the front part of the scientific notation number, then it's significant. Basically, When a number's in scientific notation, you just have to count how many digits are in the first half of the number. There are 1, 2, 3 digits here, so there are 3 significant figures. Significant figures prove to be very important when you're doing math, especially math associated with measurements from a lab. If you think about a team and the saying that a team is no better than its weakest member, well, a calculated number is no better than the weakest number used in your calculation. So if you're doing a calculation of some measurements that have been taken, you need to look at the number of significant figures in each part of the problem. So looking at number 1 here, there are 3 significant figures in 603. The 0 counts because it's in the middle. There's only 1 significant figure in 1,000 written without a decimal place. That means that your answer can be no better than the worst number, the worst with the fewest sig figs. So our answer can only have 1 significant figure. So if I take 603 divided by 1,000, I would get 0.603. However, I can only have 1 significant figure. So this tells me you no longer have to say, Mrs. Rand, what place do I need to round this to? The tens, the hundreds, what? Well, you know that your answer can only have 1 sig fig because that's the fewest from the problem. So your answer should be 0.6 for this question. If we look at the second example, 52.11 has 4 significant figures. 9.8 has 2. So my answer can only have as many as the fewest. Our answer must be reported with 2 significant figures. So when I calculate this, I'm getting a pretty long decimal, and I'm just not even going to write it all. But based on the number of significant figures and the numbers in the original problem, I should round my answer so that it has only 2 significant figures, and that would be 5.3. 2 significant figures. I want to end with just a few extra tips about significant figures. First, if you're talking about counting numbers, those are considered to have an infinite number of significant figures. For example, if I'm counting the number of students in my class, there's no uncertainty. If I say there are 19 students in my classroom, there are exactly 19. I'm not uncertain. It's not like there could be 19 and a half kids or 19.1 kids. So something like that is not going to limit the number of significant figures when you're doing a calculation. It's considered to have an infinite number of significant figures. So significant figures, again, have to do with measurements taken with instruments. Counting is not a measurement. It is exact, and so there's no need to show uncertainty. Second fact about significant figures is that using scientific notation is the easiest way to show significant figures. As I mentioned before, every digit written in the first part of a scientific notation number is significant. Third point to make is that if you're doing a bunch of calculations in a row, you should not round your intermediate results. Carry all the decimals forward and wait till the very end of a problem to round your answer to the right number of significant figures. You'll have some chances to practice in the upcoming weeks, and you will need this skill throughout your future science classes.